So lesson 1.7 continued. Remember, we're talking about the combination of functions. And so we're starting at example 6 here, and it says use the graphs of f and g to evaluate the functions. And so I'm going to scoot this up so I can see both of my graphs. Notice f of x is the graph that's on top, g of x is the graph that's on bottom. So now we're back to what we had done at the very beginning there, and we got f plus g composed of 3. The difference is this time I didn't give you an equation, I gave you a graph. So you're going to have to go to the graph and pull off your information. Well, remember, f plus g of 3 just means we're going to take f of 3 and we're going to add g of 3. So the difference is before we might have seen it as f plus g of x, which means that that 3 is just our x value. So in order to solve this, the first part here, we're going to go to our f graph, which is the top one, and we're going to look where x is 3, and I want to know what is its y value. Well, its y value is 2 plus I guess I don't really need parentheses there because they're just numbers. So plus, and then g of 3, so we're going to go to our g graph. We're going to look where x is 3, and what is its y value? 1. And so 2 plus 1 is 3. Let me erase my markings. So for B says we're going to take f times g of 1. So we're going to go find f of 1, and we're going to multiply that times g of 1. So let's go to our f graph, and remember that's when x is 1, and go find what its y value is, and we find that it is 2. Times, go to your g graph when x is 1, and find its y value, which is 3. And then multiply your numbers. 2 times 3 is 6. C says f divided by g of 0. So we're going to take f of 0 and we're going to divide it by g of 0. So let's go to our f graph. When x is 0, what is its y value? The 4. Over g of 0, when x is 0, go to its y value, which is also 4. And so we get 4 divided by 4, which is just 1. For D says g minus f of negative 1. So that means we're going to take g of negative 1 and we're going to subtract f of negative 1. So let's go find g of negative 1. So this time we're starting at the bottom graph. X is negative 1. Go up to the graph, find its y value, which is 5, minus f of negative 1. So go to the f graph where x is negative 1, go up and find its y value, which is 6, and then subtract them. 5 minus 6 is negative 1. Now, f composed of g of 4. So remember, we had written this before as let me write it here, f of g of 4. And so with composite functions, we can work from the inside out because we take the inside and we plug it into the outside. So the first thing we need to do is go find g of 4. So we got f of, now go to your g function. Oops, let me erase that on both of these. So on our g function, the bottom graph, go find where x is 4 and tell me what its y value is. Well, it's right there, so it's 0. So now we'll see that we're looking for f of 0. So I'm going to go to my f function, and where x is 0, I'm going to go up and find my graph right there, and its y value is 4. So we find that f composed of g of 4 is equal to 4. And then f says g of f of 2. So we know this is g of f of 2. And remember, we're going to find f of 2 first so we can plug it into the g function. So we're going to g of, so we're going to go to our f graph. We're going to see where x is 2, and what is its y value? On the x-axis, the y value is 0. So we're looking for g of 0, so go to your g graph. Where x is 0, go up and find your y value of the graph, which is up at 4. And so we found that G composed of f of 2 was also equal to 4. Okay, example 7 says a table of values for 3 functions f, g, and h are given. Find the values for each composition function operation below. So just be careful reading the table. It looks a little different, but what it is we have f of x, g of x, and h of x going down the left side there. And so what it's saying is if I had f of negative 3, it would be negative 4. If I have g of negative 3, it's 0, and h of negative 3 is 1. And then I'm going to skip over to like where it says 0 at the top. So that's our x value. So if f of 0 would equal 2, g of 0 would equal 1, and h of 0 would equal 3. Okay, so that's how we're going to read this table. So let's look at A. A says 2 times f of 1. Well, let's just write it out. So we have 2 times f of 1. So go to f and go to where it's a 1. Okay, so f of 1 is equal to 4. So we're going to plug a little 4 in there. So 2 times 4 plus 3 times h of 0. So we're going to go h of 0, and they're right here at 3. And then just mathematically work that out. 2 times 4 is 8, plus 3 times 3 is 9. 8 plus 9 is 17. B says h composed of g of negative 2 times f composed of g of 2. All right, so remember, we're going to work the inside out on compositions. So we're going to keep our h, and we're going to go find g of negative 2. So we're looking at our g function when x is negative 2, and we see that's a negative 1. So we got h of negative 1 times f of, we're going to go find g of 2. So you're going to use your g function when x is now positive 2, which we see as a negative 3. Then we're going to go find this. We got to go find h of negative 1. So we're going to go to our h function. And when x is negative 1, we see it's 1.5. Times f of negative 3, so go to the f function, and when x is negative 3, we can see that that is negative 4. And so we have 1.5 times negative 4, which just gives us 6. Excuse me, negative 6. And then C, we're going to take 2 times f of 3 over h of negative 2. So we have in our numerator, we got 2 times f of 3, so go f of positive 3, which we can see is 8, over h of negative 2, so h of negative 2, which is 0.5. So we have 2 times 8, which is 16, divided by 0.5, which is 32. All right, and then D. D is going to be a little hard because I still need our table, but I can't do my table and my thing on there, so I'm going to clear this. And I'm just going to write D down here. You use your spot that they gave you, okay? D says that k of x is equal to the absolute value of 3x minus 4. It says for what values of x is k of x equal to f of g of 0? All right, so, well, notice k of x is equal to both of those, which if k of x is equal to the absolute value of 3x minus 4 and k of x is equal to f of g of 0, it means these two have to be equal since they're both equal to k of x. So that means the absolute value of 3x minus 4 is going to equal f of g of 0. So the first thing we need to do is work on that f of g of 0. So I'm going to keep my absolute value of 3x minus 4. And I know I'm looking for f of, let's go find what g of 0 is. So it's g of 0 which is 1. So we're looking for f of 1 there. Well, that means the absolute value that 3x minus 4 is equal to whatever f of 1 is. So let's go find it. So we have f of 1, which is 4. And so now we're just working an absolute value problem. And so remember, the absolute value, what's inside, could be positive or negative. So that means that we're going to take that 3x minus 4, we're going to take the positive of it, and that could equal 4. Or we could take the negative of it, and that could also equal 4. And so we need to solve both of these. So we get 3x minus 4 equals 4. I'm going to add the 4, so it gives me 3x equals 8, divide by the 3, and so we find that x is equal to 8/3. On this one, I'm going to divide by the negative 1 to go ahead and move it off. So 3x minus 4 is equal to negative 4. When I add the 4, I get 3x equals 0, divide by 3, and we get x equals 0. And so there's our two solutions. We ended up with x is equal to 8/3. And we got x equals 0. Now remember, this is for letter D, okay? This is not for any of these. All right, so now let's look at some applications. So example 8 says a volume V in cubic meters of a weather balloon is given by V of r is equal to 4/3 pi r cubed. If the radius r is increasing at a rate of r of t is equal to 1/2 t cubed, where t has to be greater than 0 seconds, find the volume v as a function of t. So it told us there, we want to find v as a function of t. So we're looking for v of t. So we're going to take v's on the outside, so it's our skeleton, and we're going to plug t into it. So v is our skeleton. So 4/3 pi, those are both numbers, and then r is our variable cubed. And we're going to plug t into it, and t is 1/2 t cubed. So now we just need to simplify that. So let's see, we've got 4/3 pi. Let's leave that alone right now because we've got to deal with the exponent before we multiply. So I got this 1/2 t cubed cubed. So I can give this cube to both of these. That means I got 1/2 cubed, and I've got t cubed cubed. So 4/3 pi, 1/2 cubed is 1/2 times 1/2 times 1/2. Across the top, 1 times 1 times 1 is 1. Across the bottom, 2 times 2 times 2 is 8. And then t cubed cubed, remember, when you have power to a power, you multiply the power, so that gives me t to the 9th. And now I can just start putting this together. So I'm just going to rearrange it here first. So I got 4/3 times 1/8 pi t to the 9th. And so 4/3 times 1/8 is what? 4/24 pi t to the 9th. And 4/24 is what? 1/6 pi t to the 9th. All right, moving on to our last example, I believe. Yes, it is example 9. So 9 says the number n of bacteria in a container of leftover food stored in a refrigerator where T is the temperature of the food in degrees Celsius can be modeled by n of T is equal to 60 T squared minus 140 T plus 76. When the container is removed from the refrigerator, the temperature T of T is equal to 5T plus 3, where T has to be between 0 and 3, and T is the time in hours. So be careful because we have a capital T and a lowercase t here, okay? So A says find the composite of n of T and explain its meaning in context of the scenario. So first let's find n of T. So n is on the outside, so it's going to be my skeleton. T of T is on the inside, so it's what we're going to plug in. So we have 60 T squared minus 140 T plus 76. That's my skeleton, and we're plugging in T of T, what's on the inside here, which is the 5T plus 3. And so we're going to simplify this. So I have 60 times 5t plus 3 times itself, because it was squared. Don't distribute that square across that parenthesis because the plus sign won't allow it. We can go ahead and distribute here, so we get minus, what's that, 700t minus 420 plus 76. And so I'm going to do FOIL, or my box, on these two. So I got 60 times, this is what, 25t squared plus 15t plus 15t plus 9 minus 700t. I'm going to go ahead and combine that negative 420 plus 76, which gives me, when I combine these, I get negative 344. And so I'm going to combine my like terms inside my parentheses. So I got 25t squared plus 30t plus 9. And I'm going to bring down the rest. I'm going to distribute my 60. So I have 60 times 25t squared, which is 1500 t squared. 60 times 30t is 1800t. And then 60 times 9 is 540. And then bring down my minus 700t minus 344. Oops, and I'm running out of room here. So then we're going to combine our like terms. So I have my, just try to squeeze it in over here. It may take more than one line. So I have 1500t squared. Then I have the 1800 minus 700, or 1800t minus 700t, which is what, 1100t. And I have the 540 minus 344, which is positive 196. And so we found that n of t is equal to that. Now, it says, and explain its meaning and context of the scenario. So n is the number of bacteria, and little t is the number of hours that it's been sitting out. So what it's going to be is that this equation is going to tell us the number of bacteria that exist after it's been sitting out for t hours. So the number of bacteria technically is the number of bacteria in a container of leftover food after t hours. So the number of bacteria after little t hours. Okay, I just kind of shortened it up there, so we got the gist of it though. All right, B says, find the number of bacteria present in the food after the container has been sitting out of refrigeration for 2 hours. That's really probably how we should have worded it. The number of bacteria present in the food after the container had been sitting out of refrigeration for t hours. So, but now we know that little t is going to be 2. So we're looking for n of 2. So we're going to use the equation we just found, and we're going to plug in 2. So we got 1500 times 2 squared plus 1100 times 2 plus the 196. And so when we solve that, we get 8,396 bacteria as our solution.